Just to review, let's go to exponentials. What does a exponential growth look like?
Up. Yes.
Where does it start?
Bottom.
So it usually starts over here and then it goes up, right?
Yeah.
And then we talked about something called an asymptote. And it was on the x-axis, right?
Yes.
Remember that?
Yeah.
It's never going to cross there.
Yeah.
Because if you get half as close and half as close and half as close. And then we also learned about exponential decays. What's the only difference?
It goes the opposite way.
It just comes down. But does the asymptote move?
No.
And then we learned about something called an inverse.
Yeah.
And what do we do to x and y when we find the inverse of something? We flip it. We flip it all. Okay? So, and then we learned that exponentials are inverses of logs. So what do you think is going to happen to this graph today?
Wait, wouldn't that be over here though?
It's going to turn on its side. So the horizontal asymptote is now going to be vertical.
I thought we were doing the same.
We did it on a little Desmos warm-up, but we haven't really dug into it yet.
Wait, so the one on the right, shouldn't it like
This is a decay.
be flipped though a little bit?
Nope.
But it goes through the
Growth?
asymptote.
No, it doesn't. Asymptote. Oh, sorry.
Decay.
Yeah, this is the asymptote right here. I don't know what it is that.
Yeah.
I was thinking of logs. All right, so here we have a couple things at the top I want to fill out. First of all, it says, how are logs related to exponentials? They are inverses. Fill that in. They're inverses of each other. Log graphs, we just talked about this. If an exponential has a horizontal asymptote, what's a log graph going to be? Vertical. So circle vertical. And vertical lines are undefined, which means what letter do they start with? No. X. X equals. Vertical lines are x equals through the x-axis. Horizontal lines are y equals through the y-axis. We learned about this in our warm-up today. What does natural log really mean?
Log to E. Or
Log base E.
10 grams of E.
That's all that means. Do it. Horizontal is y equals. It goes through the y-axis. So for example, if you had this line, it would be y equals 3 because it crosses through the y-axis at 3.
I thought.
And what is the approximate value of E? Put it in your calculator.
2.17, I think. I can't remember.
Where
No.
is E?
So on your calculator, it's right above the division sign. So second E, and then hit enter. Let's round it to the nearest hundredth, so about
2.7.
about 2.72.
You had it flipped.
Did you say 7.2?
2.72 is about what E is. Kind of like pi is about 3.14. E is about 2.72. All right, so a lot of this today, we're just going to use on our calculator. Okay, so our form is going to kind of go as follows. Write this down. Y equals A.
Why?
Log of x minus h plus k. Have we seen this before?
Yeah.
Yes. Yeah. K moves the graph up or down. H moves the graph left and right. And then A value in front will stretch or compress. So this is nothing new. It's going to do a lot of the same stuff today. Okay? So has anything happened to number 1? Did it move left, right, up, down at all?
Probably.
No. So our parent function of a log has an asymptote on the y-axis. It's the inverse of exponentials. So I know it's kind of hard to do a dotted line on the x-axis or on the y-axis, but if it hasn't moved, that's where it always starts. So now, what I want you to do to fill out this table, we're just going to graph it in our calculator. So go ahead and go into y equals. Yep.
What's A again?
The stretch or compress. S/C. What's our little shortcut to insert a log other than base 10?
Math, alpha, math.
Math, alpha, math. And we're graphing log base 2 of x. And then go ahead and graph it. Let's see what it looks like. Can you see how it's like if you turn your head to the right, it looks like an exponential decay. You see that?
Sure.
Can you see how it's never going to cross the y-axis?
Yeah.
There's that asymptote right there.
Right.
So now, how do I get to the table?
Second graph.
Second graph. And it's kind of cool because the first error is the asymptote. So there's nothing to the left of it, right? See all the errors?
Yeah.
There's not going to be anything over there. It's all errors. So what I usually do is I find the first error, and then I copy down the next 4 or 5 points. So go ahead and copy those into your table. So 1, 0, 2, 1, 3, 1.58, what was the next one? 3 what?
1.52.
1.52. You can just round it. And what was 4?
4.2.
What is it?
4.
4.2.
Yes.
Now go ahead and plot those 4 points. Over 1 up 0. Over 2 up 1. Over 3 up 1.5-ish. Over 4 up 2. Now you could come up with a few more, but it's just going to kind of follow that kind of gradual curve. And remember, it goes both directions, up and down forever, because it's just an exponential on its side. So when you connect the points, make sure it kind of slides down the asymptote forever. And there's your graph. Easy enough? That's all I'm going to have you do on the test. I'm going to let you use your calculator. You can plug it in, find points on your calculator. That's what you're going to be tested over.
Yeah.
Easy enough?
We're gonna pick that next
How do you
block.
plug it in?
Just like we just did.
The calculator.
Go to what? Just like we just did. Y equals second table.
No, I mean the whole equation.
We just did, right?
Yeah.
So we went to y equals. We graphed log base 2 of x. Hit graph. And if you want to see the table, go to second graph. That's all you gotta do. Okay, now let's answer a few questions about it. What is the equation of the vertical asymptote? Look at the top of your paper. What does the vertical line start with? X equals, and it's the y-axis, which means we're going through the x value of 0. What is domain? Is that graph ever going to hit me if I'm standing over here?
No.
No, I'm safe. There's like a force field in the way. So it starts here-ish, and then it goes this way forever. 0 to... And does it ever hit 0? No, because there's an asymptote there, so it is a parenthesis. You could also write this as x is greater than 0. But we've been practicing interval notation a lot this year with parentheses and brackets. Now it might move left and right. So we'll see that in a minute. Now what is the range always going to be if we know logs go up and down forever? Yeah, it's always going to be all real numbers. Or you could write that technically as negative infinity to infinity if you wanted. Okay, I'm going to do maybe 1 or 2 more with you. Let's go to number
2.
Let's go to number 3.
Dang.
Number 3. Go back into your y equals and retype in. So math, alpha math, and we're going to do log base 4 this time of x plus 5. And then go ahead and graph. Now, do you see how it just kind of disappears into thin air? That's a glitch in these not-so-great screens, right? They're like super bad screens. Let's be honest, it's 2018, and this is the best thing that they give us. So with these awfully pixely screens, your calculator just can't handle approaching something forever, so it just disappears. You just need to know your knowledge that it's an exponential on its side, so it does go down forever.
Okay.
And it disappears right at the asymptote, so that kind of confirms that there's an asymptote there. But so go ahead and go to your second graph and find the first error. Now I knew it was going to be negative because it was over on the left side, right, where it disappeared. And then go ahead and copy down the first 4 points if someone could read them to me because I can't have that up on. What is it? -4, 0.
Negative.
Negative 3.
0.5.
0.5.
-2.75.
And
-1, 1.
-1, 1.
Yeah.
Where was our asymptote?
-5. Coincidence?
How did we know it was going to be left 5 before we even graphed it?
Because that right there.
The +5, remember it's opposite, told us that it was going to move left 5. So before we even graphed, you should have known there was going to be a vertical asymptote. So go ahead and graph your dotted line. Plot your 4 points. So -4 up 0. -3 up 0.5. -2 up 0.75. -1, 1. And then go ahead and draw that log all the way down your asymptote. So where's the asymptote now? Write it as an equation with an equal sign. X equals -5. What is the domain?
Wait, no.
Domain is left and right.
I wrote it down.
So what's the further? What's it approaching?
Parentheses negative.
Good. Parentheses -5
Infinity.
to infinity. And the range is always going to be all real numbers because it goes up and down forever. I'll do number 4 just because we haven't seen ln yet. Natural log. Is there anything different about it? The only difference is the base is e, like 2.7-ish. That's the only thing is the special base. So go back to your calculator. And there is an ln button. Did you guys see it?
Yeah.
So if you go to y equals, ln is right under log. It's over on the left side. There's a special button for log base e, natural log. And you're going to go and type in log of x. But then make sure you close your parentheses. The h value is 0. So did it move left or right at all?
No.
No, but there's a -5 out back. So what should this do?
Down.
Down 5. Does it?
Yes.
Yeah, it was kind of centered around the x-axis, and now you can see that that arc has moved down. So you can go ahead and do the table if you want. I just kind of wanted to show you there's really nothing different about natural logs. It's just the base. What is the equation of the asymptote if it didn't move left or right at all? X equals 0. Domain is 0 to infinity. And the range is always all real numbers. Okay, the last one I'm going to do with you is number 8. So go ahead and flip to the back. Number 8. Before we even graph it, what are the transformations? Let's out to the side, or you have plenty of space down below. What are the transformations that's happening?
Left one.
Left 1, write that down.
Oh.
Left 1,
And it's
Inverse or reflected.
down 5,
reflected over.
and it is reflected. I like to call it vertically because it's up and down. So before we even graph in our calculator, where do we know the asymptote's going to be?
-1.
Left 1. So put your dotted line down -1, and you can go ahead and fill in x equals -1 for the asymptote. And then go ahead and on your own, do your table. Practice that real quick.
That's not working.
0, -5, 0 or 1. What was the next? -5.6. So you can kind of see over 0 down. It's down here because of that -5. And now, how is this different? So far, they've all been doing this, right? But this one didn't do that. What did it do? It was flipped upside down. It's the inverse. It was negative. I shouldn't say the inverse. It's reflected upside down. So instead of going down, it actually goes up. And it kind of did what this green graph is doing. So just plot your points. You'll see the shape. But you can see all of the other logs looked like the red shape. This one was upside down. It looks like the green one. All right, that is all. Look at that timing.